So by now, my feeling is, if you've been taking notes, if you've been making notes, you could guess what we're going to say about 19.8, deactivating groups. If you have not been taking notes, if you've simply been trying to follow along, then my feeling is this is just going to be overwhelming. So I do encourage you to consider going back and doing that. All right. So the nitro group is electron withdrawing, and it's electron withdrawing through both resonance and induction. Explain how. Draw a full Lewis structure and consider, I didn't leave myself enough writing there, did I? A room to write. Draw a full Lewis structure and consider the two factors. Structure, that is shape, and polarity. Electron distribution, okay? Explain how it's withdrawing both those. Do that with a paragraph. Pause the video and do it now, and bring your answer to class. So, withdrawing electrons from the ring deactivates it. How so? How does withdrawing electrons deactivate it? Also, you should answer this question. Will withdrawing electrons make the transition state or the intermediate less stable, or more stable, or both? Okay, I'm not going to answer that for you either. Okay, so think about those. I hope you'll pause the video, draw a couple pictures. In this one, I gave you a hint. In this one, I'm going to give you another hint too. Draw, man, that's terrible handwriting. Draw the sigma complex in order to understand whether it's going to deactivate it or not. Okay, so let's consider ortho, meta, and para, right? Just like we did before. So suppose we've got a nitro group here, and we're going to consider all three positions. So first of all, we get a new bond formed at the ortho position, right? We've done this before via those electrons right there. That leaves a plus charge here, okay, and a plus charge here, and a plus charge here. I hope you're drawing these out. On a blank sheet of paper, you should close everything up and draw it out. Make sure, and then go back through and look at your structures and make sure they're legit. All the formal charges and all the bonds. So if it goes to the meta position, we've got a plus charge here, here, and here. Okay, and if it goes in para, right, here, here, and here. Okay, what's the hybridization? Where's my pen? What's the hybridization of that carbon right there? It's sp3, right? What's the hybridization of that carbon? It's sp2. Can you see it? What about this one? sp2. Okay. All right, so we've got two problems in this page. What are they? Two problems. Here's one. I don't know, I shouldn't put a star, it's a problem. How about a sad face? Problem. How about worse than a sad face? How about a frustrated face? Or maybe that's angry. I don't know if we do eyebrows like that. If we do sweat coming off, maybe it's a frustrated face, okay? This is me, I guess. Okay. This is bad. Bad. What's the problem with it? Well, we have an electron withdrawing group, right next to a carbocation. And that makes that carbocation even more uncomfortable. Okay? So what's that going to do? Well, it increases the activation energy and it decreases the stabilization of the intermediate. So this is bad. 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 You see that? And this is not good or bad, right? It's just not. It's not as. It's. I mean, I'm sorry. This is not good. It's just, yeah, not as bad as that, right? Okay. Okay, go practice with conceptual connection 19.13.